Okay guys, welcome to the second week of the summer internship in Computational Nuclear Astrophysics 2025. So we are doing very great, so far so good. I like the first week very much. We touched base with some refreshing our basics about programming, about command line interface, about installation and everything. You guys were awesome, you did a great job. I didn't have much queries like I can go back and forth with you and help you out with the installation. You did it by yourself. I give it to you. Okay, now we are in the second week, which is more comprehensive, which is more substantial in terms of what we are building here. So our end goal is to create a physics code which can describe the physics of neutron stars, right? For that we need to learn, obviously we are gonna do that in, we will be using some computational skills for that. So we need to learn physics also. So physics is our third week, and in this week we will be continuing building our computational skills. Okay, so our end goal is to calculate the equation of system of a particular system, for example a particular star system, let us say neutron star, and we are more interested in pressure and energy density of that system. And to calculate everything we need to know physics and computational physics, right? Computational algorithms and coding structures. And after that we will be using that for the observables like MR curve. So let's jump into our next topic. Let me quickly go through the schedule here. So I have made two changes in this week's schedule because I had some important work on June 10 and 11. I could not find any other adjustment. Sorry about that. So today we are gonna talk about June 9. Today is June 9. We are gonna talk about NumPy basically. Okay, power of NumPy. We will be discussing that, and we will execute some of the physics code, right? And then we will be having discussion and breakout session today. And on June 12 we will be talking about how to handle files through Python, and we will compare handling file with default Python options and then using pandas, which is a library. Okay, that is very important. And on the same day we will be talking about plotting, how to plot in Python. I don't know what different software you use for plotting, but we will be particularly talking about matplotlib, and maybe I will touch one or two topics of Seaborn, which is also a plotting thing in Python. And then on June 14 we will continuing with plotting with matplotlib, and then at the end I will touch a little bit about how to make your CV in LaTeX, right? So a lot of you guys have already done that. I have seen, maybe particularly I remember about Niyukti and some other person. So it stands out to me. It was written in LaTeX. Okay, I hope it was written in LaTeX. It is very good. So we will be talking about, we will be updating our CVs, like if you really want to update. So that is the particular session. So let's talk about today. So today we are going to talk about two topics, NumPy, and if we have time we will touch a little bit about prompt engineering, right? Okay, let's start with our session today. Okay, good. Okay guys, so far we discuss about basics of Python, right? And we got to know about data types and all the print statements, for loops, if conditional statements, and as well as while loops, right? We know something about it. We know what is the coding structure, what is the algorithm structure, what is the syntax we use in Python, right? We have some idea now. So again I will emphasize, we are not going to build our computational skill like a computational scientist here, we are more focused into computational physics, right. So our brain knows, you already are familiar with some of the coding, like for example C++, Fortran, you know how coding works. It is like line by line, it starts from the top and it executes all the statement line by line. So you know the idea. And Python is simple because you don't have to care about the things you are not actually using it in your code. That is something behind the scenes, like essential for coding, right, essential for computer to understand, not for us to understand. So let's continue our journey with Python. Today we will be talking about NumPy, advanced concepts in NumPy and scientific computing, and you will learn how to compare Python lists and NumPy arrays, right. And you will also learn how to create and manipulate arrays, how to use slicing, reshaping, flattening and Boolean masking, and then we will jump into how to use broadcasting in NumPy, and then we will be using some inbuilt mathematical function, right. And at last we will be solving a physics problem using NumPy. So these codes are already written. I will edit them in real time to do something creative if that is necessary, to show you some demonstration, right. So let's start with NumPy. Okay, see, in Python we have, by default we have lists which acts like an array. So list is like a collection of numbers, collection of some entities, right. We talked about this in the previous lecture. So let us say we have a list of fruits, right. We have different list of fruits, we talked about that. So we had like orange, we had apples, all those things. So we can have the same list with numbers, we already discussed about it. Now first of all I want to talk about what are, we already talked about list. Now I will talk about NumPy array. So NumPy arrays are the alternative of a Python list, and why we want to prefer NumPy array over Python list, we will talk about that, right. Why we need actually NumPy? If we already have list, Python list, why do we need to jump to something else? What are the merits of NumPy? NumPy is basically, as you can see, anticipate from its name, numerical Python. I hope it is right. So numerical Python, it is basically the library which is essential, which is very imperative in order to execute numerical tasks in Python, whether you are solving some arithmetic problem, whether you are doing some data analysis with very large set of numbers or columns or rows. Okay, so that is very important. Now whenever you want to use NumPy, okay, you have to import the library, and you can import NumPy library as such, like you can write import NumPy, right, and this is the method how you import. It is similar to LaTeX when you import a package, right. For example, use package cleavref, you use package hyperref, use package graphics, right. But I want to create an alias for my library I am importing, right. When I write import NumPy as NP, that means I am creating an alias. Alias is nothing but a second name for NumPy. For example, my name is Rajesh, my pet name like is Vicky, I mean at my place, at my home, and it is my alias, so they can call me from that name, they can call me from Rajesh. Okay, so what is the importance of this alias? I also gave you an assignment in when we were discussing about command line interface, that you can also create an alias for a command. If the command is very big, like you have to do something which is, for example, you have to execute this command grep, do all those things, right, like 4-5 things. But you can just create an alias for that. You can create an alias that whenever I type for example gr something, then it executes the whole command. Okay, so this is the power of alias. And in here, in this concept, if we are defining an alias, then whenever you are calling your using some attributes of NumPy, you don't have to write NumPy if you are not defining alias, you have to write it like this. Okay, so which is very tedious. I don't want to write it numpy all the time. Okay, I want something shorter. I want my code to use as less space as possible, right? So that's why I will just write np. And this is not just about np, you can do npp, you can do whatever you want. Make sure you are using the same here, you are using the same alias there. Okay, so if I talk about standardization, most of the people use np alias for numpy, so I think we should stick with that. Now if we want to use some other property, some other library from python, so you can import it like this. You can again import this as something else, like import sys as sy maybe. Okay, make sure it is unique, because but it is already, the characters are very less, right? There are only 3 letters in that word sys, so I would prefer not to make an alias for that. Okay, let's come back to our problem. So we loaded the packages. Okay, let us say in that words we loaded the libraries. Okay, now there might be a case when you load a library and you run your code, it might show an error, right? That means if you read the error carefully, then you will get to know, okay, the library is missing, so you need to install that. So how can you install that? You can install particular library, like if you are using pip, for example, if you are in ubuntu windows, doesn't matter. If you are using pip or you are in mac, you can just write pip install numpy or brew install numpy. Similarly, you can install um, all other libraries. But since you installed anaconda, not miniconda, so I hope you all have these essential libraries by default. You don't have to worry about that. And in Jupyter notebook, you have to write some exclamation sign. We will talk about that later, maybe in discussion session. Okay, so that was about how to load the packages, right, and about the alias. And now let's compare the memory efficiency of numpy versus list. So we will create a list in python, which is this. You know how to create a list in python. We declared a variable, okay, list underscore data, meaningful variable with what we are going to do, and we created a list. And what we have in the list, this range function. What does this range function does? It basically creates a list which start from 0 to whatever the number is minus 1. And what would be the step size? 1 by default. Okay, my VS Code is smart, so it gives me suggestion. Okay, so I will just print list data. I am interested in this guy. Okay, so I do that. I will just write list data. Okay, when I do that, I can see this is the list it has created. It starts from 0 and it ends at 999. You have to believe me, right? I can show you for 10. So when I do it for 10, 0 to 9, that means whatever you have written here, 10 minus 1, 9. It starts from 0 to 9 with step 1. Okay, let's come back to our original problem. So this is how the list is, like a short refresher about list and the range function. And now I want to convert that list to some numpy array, right? How do I do that? I declared another variable numpy underscore data, and I am using array attribute from the numpy library, and I am putting list as an argument there in that function or attribute, right? And when I put that, what happens? Okay, let's print that. Print. Okay, my code is again smart. My VS Code is smart. And then when I do that, the numpy has created an array. Now I will not call it as a list, but it is a numpy array, right? It is also showing me wrapped the text in a wrapped manner. Okay, so this is the thing. Now we want to compare. One method is we are using list, python list, to create that list, and other method is we are using numpy array to create that list or array. Okay, they are interchangeable, the words are interchangeable. Now I want to see how much memory my Python list are occupying in my space, my computer, and how much memory is NumPy array occupying in my computer. So these are the print statements with these properties. What these properties are doing basically, I needed that sys library because I want to know about what is the size of this guy, this list data, how much memory it is taking, and multiplying with the length of this data. I am getting the size of one element, then I am multiplying it with the length, right. This is the one thing. And then in NumPy, this is the method how you are getting the information about how much memory it is taking. So when I click that, you have to trust me. So Python list, the same Python list from 0 to 999 with step size 1, if we do with Python list, it is taking 8056000 bytes, which is very huge. And when we talk about the same thing in NumPy array, it is only taking 8000 bytes. So this is the first utility of NumPy, that it occupies very less memory in comparison to Python list. So that is one merit of NumPy array. So when we are playing with normal codes, right, when we are playing with, okay, let us say physics code, we don't care about this much memory or speed because we have ample space in our computer. But when we talk about data analysis or dealing with a large set of data, millions of rows, then these things matter. This will help you save your computer memory, as well as it will help you improve the runtime. So this is very important to understand. Okay, very good. Now let us continue comparing Python list versus NumPy array in terms of the time taken for the execution, right. So let us start. So again, I loaded my NumPy library as NP, okay, and then I also loaded another library which is time, and with the help of this library, I will get to know the time executing time of each operation, whatever I am interested in. Okay, now let's start. So first of all, I created a variable and I put some number in that. I assigned some number in that. So you have to follow this. So when I write 1 0 0 0 0 0 0, okay. So Python can understand this, okay, and you can also replace this with this, or maybe this, how it was written before, like this. Okay, so Python doesn't know the difference between this and this. It is same to it. Why? Because it has been written in a way so that the Python is more user friendly. So it is hard to count 0 if they are together, right. But if we can also put it like that, so Python will interpret is that it as 100,000, okay. So this is very good. Now what do I want to do here in this particular code section? I want to create a list 1 and list 2 with this size. Obviously you can anticipate how big it is when we talking about a range function. It is from 0 to 999999 with step size 1. It is a very huge array, like one dimensional array. So what I wanted to do, I want to create a list one list from this size, and then I want to create a similar list, I would say list 2 from the same size, okay. Now I created 2 lists, and now I want to add them one by one, like line element by element. So how do I add it? Okay, what I want to achieve is, see, whenever I am talking about list 1, let us say, so there is a 0 element, right, there is a first element, there is a second element, there is a third element, okay. You know how these things work. So what I want to do, I want to I want to list 2, I want to add the elements of same indices, right. I want to achieve that. So how do I do that? One thing is I do manually, start from, like, as I already written here, and then I go, okay, suggest me. It is not suggesting me, it is lazy. Okay, let me copy and then do that. Okay, it is not suggesting, sometimes it does that. List 1, okay, it suggested me something. Okay, it suggested me something. Okay, what I wanted to do. Now if I press enter, then it should also suggest me something. Okay. So one way is we can add this, we can assign this to a new variable, and we can add them line by line. It will be a lot, so I don't want to do that. So what else we can do? We can create a variable result, and in that variable, within the brackets, because of the for loop here, what I want to achieve is x plus y, right? I want to add two elements of list 1 and list 2. Okay, I want to add two element of list 1 and list 2. And how I am achieving that? For every x and y in these list, give me this. So it will add the corresponding indices, list 0 to list 1 0 to list 2 0, list 1 1 to list 2 1. Okay, that's how it will add them. We will print and we will check. What else I want to share is there is this function, right? There is this code written, piece of code written, which tells me that there is a variable start, and it is assigned to time library, and it is using an attribute from the time library. See, this is the syntax. Whenever you want to use some attribute from some library, then you do dot and that particular attribute, and then it is a function basically, and inside that function sometimes you need argument, sometimes you don't need it. So for the time being you don't need it. So this is how you assign this variable to start. Now I will change the name so that I create a unique variable for lists. Okay, and similarly I will do that here. So basically what I did, I noted a time at this particular moment. I took a screenshot of the time and I saved it in my this variable, and after that I did all the calculations here, whatever I wanted, and then after that I again created a variable, another variable, which also takes a snapshot of that particular time. Now if I do this print statement, like n time minus start time of list, what will happen? So I executed, I can see Python list addition time is this. So it basically noted down this time and basically noted down this time, then it subtracts those two. So it tells me how much time the Python took to execute this, and it is very huge, guys. List 1 has 0 to 99999 elements with step size 1. List 2 also the same. So it is very hard to it is very time consuming to add them, but for computer it is easy. Okay, now what does this zip function does? Anyone have any idea? Okay, let us do that. So yes, okay, let's
use it to zip list together so you can iterate through them.
Yeah, it extracts the list 1, it shows side by side. So whatever the entries are, for example list 0 and list 1 0 and list 2 0, it shows it makes a different column, different file where the columns are side by side. I will show you here how. Okay, let us print what I can write anything here, it doesn't matter. A comma, I want to print list 1. Okay, when I do that, I just printed list 1 and it will take a lot of time probably. What happened? Okay, it is not printing. Why? Let us print it here. Okay, maybe it is out of its memory. Okay, what I can do is instead of printing this, I can just print here. Print, and I don't need it. Okay, I still put it and for any case, and then I put comma, and then I will do zip list1 list2. Okay, zip object, maybe I have to assign it to a new variable, which is, let's say, list11 is equal to zip. This should not matter, but okay, let us see. Okay, it is not showing for some reason. I will think about that later. So okay, what I wanted to tell you was, so the Python is executing, so it executed this particular line, and it tells us like what was the start time, what was the end time, and when we subtracted it, we got something like that. Now we will do the same thing with NumPy array, right? In NumPy array, how will we proceed? First of all, we will convert our same list to NumPy array. Like, how do we do it? We will use a range function of NumPy, so which is np dot a range, and the argument is size. So what it will do, it will create the same list as this, and we will call it array. So now we have array 1 and array 2. We again did the same thing, we assigned it start underscore NumPy, and we assigned it end underscore NumPy. Okay, when we do that, and so what else we did, we just created a new variable result, and which is equal to array 1 plus array 2, and when we do that, and also I have to change the name of here, NumPy and start NumPy. Okay, so when I do that, so it executed everything. Now you can see, for the same execution, NumPy took this much of time, whereas Python list took this much of time. If you can compare, like, if you can easily compare the number, it is different by one order of magnitude. What else we can do? We can assign it to a new variable, list time. I hope I have not used it. Okay, and then I can do here list NumPy. It can read my mind. Okay, so NumPy time and list time. Now what I can do, I can create a ratio which is, again, it can read my mind. It is very good. Guys, do not use these AI tools. So I am lazy, I have to cover a lot. So when we do that, we can see we basically created I created a variable which stores the time for Python list to execute, and similarly for the NumPy, and then we have, I defined a ratio which is list underscore time over NumPy underscore time. So we can see, if we plot this ratio, if we display this ratio, if we print this ratio, we got to know that the NumPy is 3.28 times faster than Python list for addition. Okay, so NumPy is comparatively faster, but what if I increase the size of my array? Then you can say it is 4.3 times faster. Okay, let us do more. So when you are scaling your data, when you are scaling your inputs, okay, so when you are scaling your input, obviously it's gonna take more time. Okay, let us scale it more. Okay, it might take some time. I think my VS Code is stopped responding. Okay, it has stopped responding. It is taking a lot of time. So this is when you scale your system, it creates a problem, right? So you need to be careful how much you can put. So the idea is, what I wanted to tell you is that NumPy is faster, way faster than Python list whenever we are scaling our system. And to scale our system, we also require times. Okay, it executed, it took some time. Now we have some values. Okay, let me try again. I hope this time it will. Okay, Python list took 3.82. NumPy array did. It is optimizing, it is not linear, what I am observing, but it is still better than Python list. Okay, I again executed it. I increased my size of the array, and let's see, it is executing. How do we know this guy is revolving here, the icon?
Sir, for same thing, I have thought that C++ will take less time. Is it right?
C++ will take even less time, and that is a very good thing you pointed out. NumPy is based in C++. It is not a Python thing. The structure of NumPy is C++. So it is well optimized in C++. So basically we are using Python, but then the layer of an NumPy is C++. And if you do purely in C++, obviously it will be more faster. Okay, now it is running, it is taking like 20 seconds already. You have to be patient when we are dealing with large numbers. I hope, let's wait for 60 seconds, I will cancel it. Otherwise it will take forever. Or we can leave that running. Also I would like to point out, guys, have you seen any for loop here in NumPy? No, because we don't need to tell NumPy that okay, we don't need to define a for loop which basically adds element line by line or index by index. NumPy is very smart. When you just tell NumPy that okay, add array 1 and array 2, it basically by default understand that add array 1 0 to array 2 0, array 1 1 to array 1, array 2 1. Okay, it automatically does that. So that is the power of NumPy. You don't have to write your code extensively, you can just write one sentences out of it. Okay, let's keep that running. I hope it doesn't shut down my computer. Next, creating arrays and arrays property in NumPy. So we will create arrays and explore their properties such as shape. Oh, the kernel crashed. Okay, let me not do that again. Okay, guys, the central idea is NumPy is faster than Python. Now, we will create arrays and explore their properties such as shape, size, number of dimension and data type. Okay, so this is a simple array, the same array we were creating using this function here, arange. Okay, and now it is written, we are manually defining an array, right? So which is NP array, and this is the array 1 2 3 4 5. Obviously this is a one dimensional array, you can anticipate, and array 2 is two dimensional. By just looking at it we can say okay, it has one, it is a matrix. So this so the first row is this and the second row is this. So by seeing it you can just tell the dimension of this matrix, which is 2 cross 3. Okay, now let's understand. So this is obviously a one dimensional array, it is straightforward. Okay, why NP is not defined? Do you know what the error is, guys? What is missing in this cell? This is missing. Okay, I am telling my code cell to execute NP, but I have not defined what NP is. Okay, so what is the shape of array 2? It is 2 comma 3, which is 2 rows and 3 columns. And what is the size? Obviously size is the multiplication of elements in row and elements in common, which is 2, or multiplication of row and columns, which is 6. And the dimension is, obviously it is a 2 dimensional array. Okay, if it is a 3D matrix, it is a 3 dimensional array. And what is the data type of this particular array elements? So we can see it is an integer 64. Okay, you can change your data type here, then it will guess that okay, the data type is different. What else? So in Python, there are some default matrices we can use from the NumPy library itself. We don't have to particularly define it. For example, if I want to define an identity matrix, right? Let us say 2 cross 2, then I would define it like that. If I want to define an identity matrix in 2 cross 2, I have to define it like that. Okay, but in NumPy, we can use some built-in methods, built-in functions, which creates the identity or zeros matrix for us. Okay, let us see how. So let me write 0 underscore NumPy. Okay, I assigned. Okay, I assigned this. I assigned this to some variable 0 NumPy. Why I am doing this? Because I want to print it. Okay, I want to print it. So when I execute this, we can see what is this np dot zeros 3 cross 3 doing, 3 comma 3 doing. It is basically creating an array or matrices of 3 dimension which has 9 element and all of them are 0. It is creating a 0 element, 0 matrices, and the size is 3 cross 3, and I can also do that for 2 cross 2. Okay, simple. Similarly, we can create for ones 2 comma 4, 1 1 1 1, like 2 rows 4 column. Then we can create a matrices 2 cross 2 matrices where all the elements are filled with 7, and we can create an identity matrices which is np dot I eye. Whenever you do that and you put the the order dimension of that particular matrices, it will print that identity matrices. Okay, we can actually print that. Let me assign some number, some variable here, identity equal to, and I did that. Now what I will do, I will do print, and I love my GitHub Copilot, and then I got this identity matrix 1000 0010 and all these things. Then we have np arrange function. We have already used that. So if we are giving some initial and final points here, see initial point 1, final point 10, then there is a step size, then it will print something like that. I don't need to print it, right? It is straightforward. And then we have np dot linspace. Okay, and this is very important. This is different from arrange. Here what we can do, we have a start point, we have a starting point, we have an ending point, and then we have some number. So what linspace will do, it will divide 0 to 1 in 5 different section, 5 different evenly spaced equal section, and it will give us an output something like that. Okay, so basically divided 1 by 5, and then it kind of using for loop it has created this. Okay, so you don't have to use for loops. If you are doing in Python list, you have to achieve this using for loop, or there might be something in the list, but NumPy it is linspace. Okay, what is next? Then we have this guy here. Again I am using, it will show me an error. Okay, I imported my NumPy, and what I am trying to do here is I created an array is equal to np array 1 2 3, and I declared the data type is np dot float 32. Okay, I manually declared it. Then I printed the data type here, and it printed float 32. And now what I want to do, I want to typecast it. I want to change my data type to something else. How can I do that? I created another variable and I used this function dot as type. Okay, and this is not a NumPy function. It is a Python function. What I am doing is I am changing the type as type using as type of this array to what? NP dot int 32. So, I am basically converting float to int. So, when I do that, I printed that again in the next line. I saw that it is a integer. And how can I confirm that? I can just put this thing here and I will just write array underscore int. Okay, when I do that, it is int 32. So, you can, this is the way you can typecast your, this is the way you can typecast in Python or NumPy. Okay. So, this is the way you can do that. Now, what else? Then we want to understand the indices, right? So, let us do that. Understanding the indices. Okay. So, when we do that, so we again have array np dot array, we have some numbers here, which is a list. So, which is also simple. I have told you, like if you want to print the first element of an array, it starts from 0, it does not start from 1. So, in the Python the index starts from 0. So, when you print array 0, that means it will print 10, right. Similarly, if you print array 2, it will print 0, 1, 2, 30. Okay. But if you are putting negative indices, then it will start from the last item and go back towards the left. So, let us say minus 1 is 40, minus 2 should be 30. Okay, pretty simple. So, you can use these indices pretty well. And then we have what? We can also slice it, right. So, slicing, I was lazy, I should have put this before. Okay, slicing the arrays. Okay, so we can also do that. So, how can we do that? We have this array and I only want to print a particular set of numbers. So, I have a set, okay, should not call it set is something different in mathematical language. It is a set of numbers, normally speaking, casually speaking. So, array, I want to display array from first element to fourth element, right, and here first is my second. So, it will display obviously 20, 30, 40, and when I do like that, column 3, it will show me first 3 elements, it will start from here, first 3 elements, and when I am doing double column, it will show me every second element, it will show me whatever every third element or every second element or every first element. So, it will do all these things, like it will skip those places. Now we have something called array indices. We can assign array to a new indices, right. Array indices. Okay. So, how can we do that? So, we have this again, why it is working without NumPy, maybe I have already loaded it. Okay. So, array indices, we were there. So, when I click here, I have array is equal to NP array, again I have this array, then I defined another array which is a list now, not IDX is equal to 0 to 4. Now, I want to correlate these two. So, how do I do that? I assign, so I only want to print array with these particular array of NumPy with this particular list indices. Okay, so how it will execute? It will do array 0 first, which is 10, and then it will do array 2, which is 30. Okay, it will display, and then it will do array 4, then 50, right. It will execute step by step. So, this is one of the other utility of NumPy. Then we have downcasting, something called downcasting. Okay. Now I have an array which contains these number 100,000, 200,000, 300,000, and I declared the data type of it as integer 64. Okay, sometimes you don't need integer 64, right? We are doing calculations in our computer, we do not care about memory, but when again we are dealing with large set of data, we don't need to we surely need there to use like data types which can handle, which can occupy more memory, which can store a large amount of data or numbers. But when we are playing with numbers like okay 6, 4, 7, we are not dealing with extensive number like 100,000, 200,000, we don't need integer 64, we don't need a bigger data type, we can use our smaller data type and it will help us save memory as well as save time. Okay, so one way we call it, we can use downcasting. Okay, downcasting. So what does this downcasting do? In downcasting, so we defined a array, so we have defined it as integer 64, and then we are downcasting it. How? We are using this array in NumPy we declared, and we are using this Python function .as type, and we are assigning it to a new data type, or in other words we are downcasting it from integer 64 to integer 32. Then we are printing okay what is the array output here. So array output is the same and the data type we already changed. The example is similar to what we discussed before, but I just wanted to emphasize one thing here, that when we are dealing with like some light calculations, light computations, so we should only use integer 32 or something, float 32, we should not use that is a good practice. It does not matter now, but whenever you are you try to optimize your memory, optimize your code, it will help you a lot. Next, so next is about let us check the memory, right? Okay. So continuing our discussion about the data type, how much memory it is occupying. So we have a array which is integer 64 as declared 1, 2, 3, and then we have integer 32 1, 2, 3, same array but different data types. Now I am printing how much memory they are basically covering. So you know one element covers 8 bytes and we have 3 elements, then it is covering 3. When it is defined as integer 64, one element covers 8 bytes each. When it is defined as integer 32, it covers 4 bytes each. So with simple calculation we can get to know that okay 24 bytes it is for integer 64 for the same array, and 12 bytes for the same array in integer 32. Now this is a very simple example, when you scale it, it will create a huge difference. Okay, so that is why it is very important. Now what else? Very important property of NumPy. Okay, let us go through this particular example. Now what I wanted to do is I wanted to show broadcasting to you. What is a broadcasting in NumPy? Broadcasting. Okay, so in broadcasting, so this I will show you what broadcasting is. Let us go line by line. So we created an array, okay, then we created an empty list in Python. It is just an initializer. Okay, I have some list which is empty. Okay, then I want to put some data in my empty list which is result, right? In that case what I will do, I used a for loop and I created a variable num in what, this array. So what I am telling my Python code to, and obviously this is an indentation. So what I am telling my Python code to, so append, that means add to this list result. What do you want to add? Each time for each number just add num to power 2. Okay, so this is an index. If you are confused with num, let us just write it I, because we are more used to I. So what it is doing is, for each element of array it is creating a square of it, right? This is an arithmetic operation and it is simultaneously appending this thing to here, right? So, let us execute that. When we execute that, we got to know that for each element 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25. That is how it is creating a that's how it is filling the this particular list. Okay. Now, this is one way of filling the list, squaring it. Now, if I want to do something else, if I want to add a number to each element of this array, how would I do it? One way is I define the indices array 0 plus 10, array 1 plus 10, array 2 plus 10, array 3 plus 10, array 4 plus 10. That is a tedious work, right? We have to line by line, or maybe I have to use for loop as I demonstrated above. But in NumPy it is smart. So, you just have to write plus 10. When you just write plus 10 to an array, what it will does, it will add plus 10 to each of the element by itself, because it is smart, it is optimized. And also let us do this thing, result square squared, and I will just write not array, okay, and okay. So, when you do that, and I also print result squared, see the power of NumPy here. So, what I did, I just defined a variable that square, give me a square of this array. So, I do not have to do all this thing. See, I just wrote this thing, okay, array, this ARR is my array, and I squared it, did this arithmetic operation, and it automatically understood and created the square of each elements. So, you do not have to write all these things, you are secured, okay, your code is optimized, your code is with less number of lines. So, that is one of the power of NumPy, and this is called something called broadcasting. Okay, what is next? So, how much I have? Let me see. Okay, just 2, 3, 4 cells, 2, 3 more cells. Okay, now where was I? Reshaping, flattening, and Boolean masking, which is also very good, very simple. Sometimes we might need to reshape our array, right? We are working with one dimensional array or multi-dimensional array. I want to reshape it to some other array, like 2 to 1 dimension, 3 to 1 dimension, 3 to 1 dimension. How do we do it? Okay, this is how we do it. So, first of all, we started with an array. We created an array NumPy.aRange 9. It creates an array from 0 to 8 with step size 1. Now, I want to reshape, obviously now if you print it, okay, it is giving me output, do not give me output here. So, if I do that, if I do print ARR, let me put some print statement here, so that I know where I am right now, what I am printing. So, ARR is 0 to 8, which is a one dimensional array, right. Now, I reshaped it. So, these are dummy variables, you can put anything you want, it should be meaningful. So, what you are doing is array dot reshape 3 comma 3. So, what basically you do, you use the reshape function and you reshape this array to 3 comma 3, and when you do that, let us print that. It is already been printed here. So, I will just print it here, it does not matter, because we are using different names for different variables. So, I did reshaped and equal to sign, and when I did that, I see my reshaped array, it was before a one dimensional array, now it is a 3 cross 3 array. So, I changed it to 3 cross 3 array. What if I add one element here? How will it do? Can it reshape to 3 cross 3? No, because the number of elements are not 9 now. So, it should match the order, it should match the shape of the array, whichever we want to reshape it into. Okay. So, that is pretty obvious. So, I will turn it again back to 9. So, can we do it 2 comma 2? It will fail because the number of elements are larger. Okay, so it will only work for 3. How will I do that for 2 comma 2 if I change it to 5? No, not 5. Why? 0, 1, 2, 3, 4. Okay, I need to change it to 4. Okay, very good. Now, then we have something called flatten. So this was like going from lower dimension to higher dimension. The first demonstration was. Now we will come back from higher dimension to lower dimension. Let us see how. So I reshaped my array from one dimensional array to 2 cross 2. Now I will go backwards. I will do 2 cross 2 to one dimensional array. How would I do that? I will use dot flatten property attribute. So how do I do it? Reshape dot flatten, and then I print flattened. Okay, again I will put something meaningful so that I know which print statement belong to what. Okay, when I do that, it is basically telling me flatten. Okay, let us this print, mute this and run. So I can see print flatten is equal to flatten, and it has converted my 2 cross 2 to 1 cross 1 dimensional array. Now I can also print reshaped like this. So this is something if you want to show a particular element in your array or matrix. For example, I have reshaped matrix. If you remember, reshaped was 0, 1, 2, 3, and I want to print 1 comma 1th element. Okay, how do I do that? If I do that, obviously it will show 0, 0, 1, 1, 0, 1. Sorry, it is 0, 0, 0, 1, 1, 0 and 1, 1. So if I am doing 1, 1, it will print this item 1, 1. Okay, and then we have mask. This is called Boolean mask actually. Okay, let me light it right here. Boolean mask for element greater than 4. So what we are doing is, so if I created a mask, right, in which I put a condition that if reshape which is an array is greater than 4, then give me that reshape with that mask. Okay, so obviously what will happen? So if it is greater than 4, now it is not greater than 4 because our array is, the number is less than 4, so it will not showing anything, it is not showing anything, right? But okay, let me mute my print statements here so that it doesn't confuse you. Okay, I muted all the print statement. Now I have only one. Now if I do 9 here, obviously, okay, it is creating problem here. Okay, let me change the dimension here, and when I do that, it is showing me 5, 6, 7, 8. Why? Because my array has elements 0 to 8, and I have given it this condition that print everything with that particular mask, and the particular mask is reshape is greater than 4. So whenever the elements are greater than 4, just print that. That's how we get a slice of the particular array in NumPy. Okay, so far so good. Now we have broadcasting. We already discussed about it, but there is another example of broadcasting, which is we have an array which is 2 cross 2, and we have another array which is 1 cross 1, which is one dimensional array. Then we have a third array which is not an array, just a number. It is defined it as an array. So we already discussed that when we can add a matrix to a number in NumPy. We can add a one dimensional array to a two dimensional array in NumPy, which is weird, but it is what it is. So it helps us do the calculation easily. Then we have normalizing data. Okay, so we can calculate the normalized data, basically, which is this function data minus mean underscore standard deviation, right? I will come back to you, but before that I want to discuss about built-in mathematical function. What are the basic built-in mathematical functions? So I have only shown very simple mathematical functions here, which are very useful in statistics, right? So you have a large set of data, you want to calculate its mean, standard deviation, variance, what is the minimum value of data, what is the maximum value of data, what is the sum, what is the product, all of these things. So if we don't use NumPy, you have to write the whole code to calculate mean. You have to write manually, like, okay, create a for loop, take all the elements, sum them, and then divide it over the number of the elements. So it is a huge task, right? But if we have NumPy, we have already some inbuilt functions for us. For example, we have .mean function, which basically calculates the mean. So if I have some array 1 2 3 4 5 for simplification, the np.mean will give me the mean. So do you guys want me to tell how to calculate mean, or you guys are okay, like, okay, mean is the sum of the number divided by n, and standard deviation is also defined, like it has a formula, and then we have variance, right? You can just look at in the internet, or I will provide you some notes for that. So it is very simple. You wanted to create some mathematical quantity, let us say standard deviation or variance or minimum or maximum, sum, product, anything. In NumPy, you just have to use that particular function and you put your array as an argument, and then you do wonders. You just click one button and it will give you everything. You don't have to do any sort of tedious thing with your coding. So 1 2 3 4 5, let us discuss the simpler one, which we can easily see. np.minimum will give me the minimum number among these elements, which is 1, and then maximum is 5. Obviously sum you can do element by element sum, product element by element product. So it is very simple. Otherwise the mean, this code will be around like 4 5 lines, this may be 7 8 lines, 7 8 lines, 2 3 lines, 2 3 lines, maybe 3 4 lines, 3 4 lines. Okay, so this is like a wrap up of like 20 25 lines just in few lines. Okay, so this is also one of the very important feature of NumPy. So I have not included gradient, derivative and integration so far, but we will talk about that eventually when we know how to deal with pandas. So when we are ready with pandas, we have some input to put in, right? We can input some large data sets, and then we will be more comfortable in gradients and calculating numerical integrations. Also, I would like to tell you guys that we are not touching SymPy. We are only talking about NumPy in this internship, but SymPy is also very important. For example, see, sometimes we want to solve the derivation, we wanted to do the matrix multiplication of some matrix in a symbolic manner. I hope you guys know the difference between symbolic and numerics. Okay, let me give you an example. So numerics are when you create derivative numerically. So you have a line, pressure versus energy density, and you want to calculate dP upon dE, pressure upon dP upon energy density, or you want to calculate, let us say you have a line, pressure versus baryon chemical potential, and you wanted to calculate the baryonic density out of it just from the arrays, just from the columns. How do you do it? If you have like numbers, if you have arrays, you have data, then you simply use NumPy derivative, which is gradient, and you calculated that from the data, which is basically dP by d mu, okay, which is number density. Now if we have, let us say, some symbolic equation, like we don't have points, but we have some polynomial equation, x to power 2 plus 2x plus something 5, and you want to calculate its derivative symbolically in the code, like x square will be 2x, 5x will be 5, 2x plus 5. It is not numerical, it is symbolic. We are using symbolic as x and y. Okay, then whenever we do that thing, we are basically using symbolic calculation, and we are using SymPy, which is very powerful. I will show you my code for some motivation, right? NumPy I use extensively whenever I am dealing with numbers and all those things. We will use this when we will derive, when we will create a code for equation of state using some model. which is a task for our next week. And then we have a normalizing data. So, normalizing data is something like that. Some sort of function we wanted to calculate, and we have some array with multiple dimensions, and we calculated that, and it will create a dimension, it will create a normalized data. It is simple, you can just go through it. Now, last very simple example, gravitational potential on a grid. It is very simple physics problem, but for the sake of completeness I just put it. So, we will compute the gravitational potential of a mass at origin on a 2D grid. Okay. So, gravitational potential of a mass at origin on a 2D grid. So, we have a 2D grid, and we want to see how the gravity is changing with respect to space and time. Okay, let us say x is space and y is time, or maybe just don't forget about time, it is just x and y, both are two dimensional space. Okay. Now, how do we do it? We created a function, we created basically our grid. Our grid is from -5 to 5 with how many points? 500, and same grid is in the y. It is a 2 cross 2 grid, 2 dimensional with same dimension with x and y. Now, so we created a variable x with basically this is a list, this is also a list array, I would say now. Okay. Now, I want to create a mesh grid out of it, like mesh grid is like column. Now, it is a column, like one column and two column together. So, x comma y, I created a mesh grid, and mesh grid is a function of NP. And then what I am interested in, I am interested in calculating the gravitational potential. So, you guys are smart, you know how do we calculate gravitational potential, which is simply U is equal to minus Gm upon R. Okay. You can also calculate force, it is up to you. Then we need to define some constants, we need to define our gravitational constant, we need to define the mass, okay, mass of earth. I have not defined particularly which system is it, but I hope it is a mass of earth. So, guys, you also know the units are very important, right? So, whenever we are dealing with a physics code, make sure we are dealing with the same units. So, if we are using the SI units throughout the code, we should use SI units throughout the code. If we are using some other system CGS, we should use CGS system throughout the code. Okay. So, it is very important. So, we have mass, we have gravitational constant, then we have this guy here. Okay. I do not want to be more descriptive. Now, the thing is, we know the formula U is equal to Gm upon R. These are the constant, G is the constant, M is the constant, but I am more interested in to calculate radius, right? And radius is something, this is a polar coordinate thing, polar coordinate in polar coordinates, right? And x and y are Cartesian coordinate. So, we need to go from Cartesian system to polar system, right? How do we do it? If you remember in your BSc first year classical mechanics, we have this, like how to go from Cartesian to polar. So, x is equal to cos sine theta, y sine theta, and you put it, you square it, then you get cos square plus sine square theta, and then you get something like x square plus y square is equal to r square. So, r square is nothing but x square plus y square square root. Okay. I do not know why this thing is here, let us forget about that. So, this is the distance from the center of the earth where we are interested in calculating the gravitational field. Now, so we have R, we calculated it from the mesh grid points, which is x and y, and now we have some print statement which is telling me what is the maximum potential and what is the minimum potential. So, you can also print here. Okay, let us do, it can read my mind, always it can read my mind. So, I am giving you the potential here. So, since this is a 2D grid, it is hard to see, and it has a lot of numbers here. So the point is, what I am trying to say, U is a mesh grid. Why it is a mesh grid? Because x and y is also a mesh grid. So we have a 2D surface, right, and in each point we have some value of the potential, and from that 2D grid we are calculating the where is the maximum potential and where is the minimum potential. Okay, and where is the maximum potential? It is, what is the value of maximum potential? It is this. Maybe we do something, we can do that. Actually we can plot this. So we will learn this when we deal with matplotlib, because then it will be easier to see the mesh grid like visually, and it will also be easier to plot it in a different perspective, so that where is maximum, minimum with different color schemes or color bars. Okay, so that is one of the thing we are gonna do in next few days. So far so good with this. Okay, okay, I was there. Okay guys, how was the session so far? Do you like it? I mean, were you able to comprehend? Okay, very good, very good guys. So now let me show you one thing. SIMPy, I wanted to tell you. Research collab. I didn't plan to share it with you, but okay. But since we are discussing about SIMPy, I just wanted to give you some of the idea. Okay, so this is what we were trying to do some derivations in our Python code, right? And this is the matrices we are defined as in SIMPy. So SIMPy we have similarly, as we import NumPy as NP, we can do SIMPy as sim. So these are the thing, like what I wanted to tell you is we can do actual calculation in the symbolic form itself, and we can calculate the matrices. So right now I don't know whether it is in a running state or not. I actually don't remember. I did it a long time back. So it is displaying some matrices here. Okay, it can also display it nicely with pp print, as so far I remember. Let us do pp print m. Okay, so this is pp print. It is taking a lot of time to calculate. So this was the code I wrote in SIMPy. Actually I wrote it with my friend together. So this is pp print. So when you are basically doing pp print, it display it as a matrices. So still you can relate it is showing it like a matrices, and it is easy to comprehend this thing I am talking about here, from here to here. Okay, I am not able to highlight. Yeah, from here to here it is showing it as a matrices. So it is very important. You can calculate daggers, you can do wonders with it. Okay, so this is one of the thing you can use, you can learn by your own. Okay, now what else? You already put your attendance. Then I wanted to discuss about the assignment I was preparing for today. See guys, I have put some physics problems for you. I will again say, do not use any AI tool, do not use ChatGPT or anything, just use your mind. Use your mind to create these codes, right? And it is very simple, they are very simple. So this is something I have not told you today, but I wanted you to be creative and search on Google, like how do we use @ operator and dot operator in NumPy, right? So you guys, I will share this soon and you will get to know about this thing. If you have any problem, you can always tell me. Okay guys, that was my presentation, my lecture so far about NumPy. I hope you enjoyed it. If you're not, I'm always welcome for the suggestion. Do you have any question? No. Okay, so do you wanna have a short presentation on prompt engineering or not today? What do you think? Okay, mesh grid I will do, I will tell you. Just thumbs up and thumbs down, guys. You wanna have some short. Okay, prompt engineering. Okay, okay, I will take, guys, 30 minutes. When I talk I don't remember time. Okay, let us answer mesh grid first. I hope I have my iPad here. If I can show you visually, it will be, easy. Let me try to phrase it again. See, we created one array. Okay, so this is a separate array. If I print x, print y, okay, let us do this. So you can see my x has a lot of numbers. Obviously it starts from -5 to 5, and it has divided 5 by 500, and it has like various equal evenly spaced segment throughout this, right? Similar for y. So I'm gonna mute it. And then what is mesh grid doing? So mesh grid is taking x element by element, and it is, for each x it is creating a y, corresponding y. Oh, I muted everything. So before mesh grid, x and y are not interlinked. X is something different, y is something different. But when I applied this mesh grid operation, then what it does, for each y, there is some corresponding x. Now there are two columns. Before there were some two different files. One is file 1 with one column, one is file 2 with one column. When I do mesh grid, it basically created a mesh of these two different files, column 1 and column 2. Now they are corresponding to each other, xy, xy, x1, y1, y, x2, y2, x3, y3. Okay, now before it was a one dimensional system separately. Now I have the grid, like a two-dimensional grid, where each point have some value, right? X, y, x1, y1, x2, y2. You have to imagine it for this case. But be with me whenever we are doing some visualization. I can explain it more clearly, or I should also include my iPad within the next session, so that I can do some drawing. It will take 5 minutes if I do that now. So stay with me, I will tell you in a more clear way. Okay, so let me stop this recording, because I